In the previous lecture, I hope this sum is understood. We started as well as finished this sum. Yes. Turing machine for performing following operation, which is removing or erasing the block of blank between two blocks of ones. Next, sum number 12 now. Let me copy the problem statement for 12 number sum number 12. It says that you need to design Turing machine that erases all non-blank symbols on the tape. So the sequence of non-blank symbols won't have any blank spaces in between them. So this might be specified or might not be, but this will always be your note while writing the solution. If it is specified in the sum, well and good. Otherwise, you should start your solution by this note that the sequence of non-blank symbols does not contain any blank in between. I will give you the visual representation and try to build the solution for this, design the TM for this, that is transition diagram. Now in the sum itself it is said that you need to erase all non-blank symbols. So the value of sigma or summation is not given here. Summation is finite set of input symbols. So here you are at liberty to decide which symbols you want to work with. So we will consider, let me copy summation. We will consider, let non-blank symbols be summation equal to, you may have 0, 1. You can have small a, small b also. Let W be any string, say 1, 0, 1, 1. So now you need to, this is the example of input string you want to work with. Now you need to give the visual representation of input on text as always, and with the help of this you will be building the logic for designing of Turing machine. So if this is the input on tape, the expected output again, go to the sum and read it. It says design Turing machine that erases all non-blank symbols on tape. So when you erase a non-blank symbol, blank will be left in the cell. So here you will be left with, this B will be blank, so copied as it is. This is first non-blank symbol. This is erased, moving to right. 0 is erased, moving to right. 1 is erased, moving to right. 1 is erased, moving to right. You encountered B, so now you will stop here. So this will be the output on tape. So this can be the simplest program you can design Turing machine for. So using this logic, take a minute and try to draw the Turing machine. What is the logic? As always, we have started with the leftmost symbol on the input tape. It is the non-blank symbol. As per the given problem statement, you need to erase all non-blank symbols. Erasing means capital B will take its place and you are moving to right. Erased, moving to right. Erased, moving to right. Erased, moving to right. When to stop is the criteria here. So as soon as you encounter B, you stop. No action is done regarding read write head. Take a minute, try to draw this. Mics are provided. If you have any doubt, you should ask. Anyone would like to answer how many states will be there in the Turing machine? As always, people are not interested in answering. So let us continue drawing. So you will start with Q0 as the initial state. This is the simplest sum which can be asked for the designing of Turing machine. In Q1 itself, if it's a non-blank symbol, you will stay in Q1 after performing action. How many non-blank symbols are there? 0 and 1. So what action you are supposed to do for 0? If it is 0, erase it, move to right. Another non-blank is 1. If it is 1, erase it, move to right. So there are only two non-blank symbols. For both of them, the action is same and you stay in Q0. As blank symbol is encountered, it's B. So if it is B, let it be B, perform no action. And you go to accepting state, which is called as alt. So this will be the Turing machine for the asked sum. Take a minute, go through example number 12. I hope I am unmuted. Yes. Even if you are taking some other input symbol, say small a, small b, or ABC for that matter, design will remain same, only the input symbol will change. Here 0 and 1 are the input symbols. In case of ABC, you'll have A/B, R, B/D, R, C/B, R. So here the main thing is you should understand the logic or meaning of the problem statement, what is asked. So the way of asking is simple. The only thing is you should go through it 2-3 times and then give the visual representation of your understanding and what operations you are performing, and then accordingly you need to draw the transition diagram. So if there is no doubt, next sum, question number 13, which is asked so many times in the university exam. What it says, design Turing machine which accepts all the strings of the form a raised to n b raised to n, where n is at least 1 and rejects all other strings. Now the second part of this sum says that it is rejecting all other strings. So what this means? It means that the invalid strings are not ending in halt state when you start from the Q0. They are stuck to non-accepting state. So that will mean rejects all other strings. Minimum value of n is 1. So the smallest string it should accept is AB. Then for this a raised to n, b raised to n, we have said that as DFA or FA does not have memory, it cannot remember how many A's are there on the tape. So it cannot verify whether same or equal number of B's are appearing. So it's not possible to draw DFA for a raised to n, b raised to n, and that's why we have said that memory is required and then PDA was there to help you. So FA plus stack is giving you PDA. For same type of sum we have constructed PDA. So again I would like to repeat it one more time. Even if they are asking design TM which accepts a raised to n, b raised to n, 50% of the students will be giving the solution for PDA, because you can have a PDA for this as well as Turing machine. So while writing the solution, you should be clear whether the PDA is required to design or Turing machine. Here we are going to design the Turing machine. Again you need to remember that the minimum value of n is 1. So when you say minimum value of n is 1, your initial state Q0 should not be final state, or else it will accept the string of length 0, that is null string. So let us start with the solution. Here you can list it likewise that alphabet consists of A, you can have some value of n. So your W will be 3 A's and 3 B's. Accordingly, you will get the input on tape. Visual representation will start with B and then 3 A's followed by 3 B's and again blanks. You need to remember that length of tape is infinite. Now take a minute and try to think about this sum without counting. How you will verify that if A is appearing for 3 times, B is also appearing for the same number of times. Again, consider that the tape is laid from say Bharti Vidyapit to CST station. You got bike with you. Thousands of A's and B's are there on that tape, and you without counting, because you don't have variables with you which जिसका value you will be incrementing. So manually, mechanically, how this operation will be done. Take a minute, try to think about this. So mechanically, if you are supposed to perform the task, can you say that A is the leftmost symbol encountered? Let me, type of operation is not there in Excel, right? So can you consider that for this A encountered, you will strike off one B and then again for this A encountered, you will strike off this again for this A, you will strike off this B and then again you will come for A which is not there and then you will go to right end to make sure that B is also not there. So if this is the case, that for each A encountered, corresponding B is striked off and in the process all input symbols are processed and exhausted, no extra A or extra B is left, then you can be sure that equal number of A's are there as that of B's. So this is the logic we will be using. Now what you will do is, if you encounter this A, you will convert it to X and then you will go to the rightmost end till you encounter B, you will go to its left. Left में you will find this B. You will convert B to Y. So a pair of AB got marked. This is X, this is Y. Now you will move to leftmost end in search of this A. How you will locate this A? You will keep moving towards left till you encounter X. As soon as you encounter X, you will go to its right. Right में जो भी A है, that A you will convert to X. So this becomes X. Keep moving towards right till you encounter Y. As soon as you encounter Y, you will move to its left. Left में if there is B, it's converted to Y. Again, repeat the same logic. Keep moving towards left until X is encountered. Now this is the X you will encounter first. Move to its right. ये वाला A is converted to X. Keep moving towards right till you encounter Y. Move to its left. Compensating B is converted to Y. Keep moving towards left till you encounter X. Go to its right. You are hoping to encounter A, but you encountered Y instead. So this will be the accepting condition. If number of B's are more, what will be the scenario? Scenario will be like this. If number of B's are more, you will encounter B instead of A to the right of X. So it will be rejected. I hope this is understood. So let us draw the machine, always starting with Q0. You should also try, rather take a minute or two and try to draw it. The logic has been explained to you. Try to draw it yourself. This is the frequently asked Turing machine design problem in the university exam for 10 marks. As you start with Q0, what you did initially, यहाँ पे क्या है A, this was B. You know that this A is leftmost A, so you directly converted it to X. So what is the equivalent transition definition for this? Del of Q0 comma A is equal to Q1 comma X comma R. I hope these things are understood. You encountered A, convert it to X, move to R. So this becomes X. Moving to, we won't have loop for this because otherwise all A's it will go on converting into X. You don't want it. Leftmost wala A you want to process and then go to rightmost A and then process B. So we are not having this on looping. A dedicated transition or edge is there. You are in Q1. Q1 may you encountered A. What you are supposed to do with this A? Skip it and keep moving to rightmost end till you encounter this B. So same action is performed for A as well as B. So here now you will insert a loop because same set of action you need to perform for two different multiple A's and B's. So if it is A, let it be A, move to R. Similarly, if it is B, let it be B, move to R. As soon as you find E, so you say that if it is B, let it be B, move to its left. Left may you encountered B, you are in Q2. What you are supposed to do with this B? Convert this B to Y. So suppose this is Q3. If it is B, convert it to Y, move to leftmost end now. How you will mark the leftmost? ये B आपने Y में convert कर दिया. You are moving to left. While moving to left, you are encountering B as well as A. You skip all of them till you encounter X. तो यहाँ पे you can have a loop saying if it is B, let it be B, keep moving to left. If it is A, let it be A, keep moving to left till you encounter X. X encounter करते ही you will be moving to its right and then repeat this cycle. So to repeat this cycle, if it is X, let it be X, move to its right. And then X के right पे what you are finding? A. A के साथ क्या करना है? Again same cycle. So what this cycle says? Convert this A to X. Move to, you are in Q1 now. Move to right. A should be skipped as well as B should be skipped. I hope this is understood. Till you encounter capital B. As soon as अभी capital B आपको करना है, B should be skipped. Instead of capital B, now here you should say you may encounter Y. If it is Y, let it be Y. And then उसके left में. In the first go you encountered B. But now you need to move to left when you encounter Y. So above this B slash B comma L, we have also added Y slash Y comma L. So Y तक गए आप, you have kept this Y as it is and now you are moving to its left. So left में B is there. What you should do with this B? Convert it to Y and keep moving to left until you encounter X by skipping A and B. X आपको मिला, you go to its right and you have A. Again you are in Q0 and you repeat the process. अभी ये process में A is converted to X, you are moving to right. Right में B should be skipped, move to right. As soon as in Q1 you encounter Y, you let it be Y, move to its left. You are in Q2. Q2 में you encountered B. You are supposed to replace it with Y and move to left. Move to left. You are in Q3. In Q3 you encountered X. If it is X, let it be X, move to its right. अभी right you are in Q0. You are expecting A, but you got Y. So this will be your accepting condition. If it is Y, let it be Y. You can say you are moving to right. Q4. You are moving to right. Right maybe you will get Y. Skip all the Y's until you encounter B. So if it is Y, let it be Y. Keep moving to right. As soon as you encounter B, halt. By this you are making sure that small b is left. Move, skip, move. B is obtained, let it be B, stop. Halt. So take some different value of n and try to process a raised to n, b raised to n. Mics are provided. If you have any doubt, you should ask. Smallest string, we have said that AB will be accepted. How AB will be processed? A is converted to X, B is skipped, then you encounter blank. So you go to its left, you will find this B, which is converted to Y. It is moving to left, left में X आएगा. You are in Q0 again back. X के right में you will find Y. So it will be here. You are in Q4. Again you move to right, you will get a blank and then you reach halt state. If it's a null string, only B will be there. So from Q0 you start. Whether capital B का transition is defined from Q0? No. So it will be stuck in Q0, it won't proceed. So that way null string won't be accepted. Now here sigma or alphabet consists of A comma B, whereas gamma, let me copy this symbol, gamma is what? Finite set of tape symbols. So here gamma is what? XY. B is, capital B is represented by itself B. So this is the first tuple, second tuple, third tuple of 7 tuple formal definition of TM. Q0 is represented by Q0 itself. Capital F is what? Only halt state, only one accepting state is there. So halt. Then capital Q is what? How many states are there? कहाँ पे लिखना चाहिए? इधर. Capital Q is what? Q0, Q1, Q2, Q3, Q4, halt. Q4 and then halt. So these many states are there in Q. How many tuples का values we got? 1, 2, 3, 4, 5, 6. Seventh वाला is what? Delta. Transition function, mapping function. Mapping function says what? Let us copy this thing. And then you can have the transition table also for this. Mapping function a state and symbol either from sigma or gamma. It can be B also. Gives you next state, symbol on tape and action. So here if you try, let us have it side by side. If you say this is your Q0, this is your Q1, this is your Q2, then input symbols are A, then there is B, then there is capital B. Apart from this, anything? No. So let us try to populate the transition table. Q0, while processing small a, gives you next state as Q1, that a is converted into small x and is moving to R. Q0 B का transition is defined? No. So it's dash. Capital B का transition is defined? No. It's dash. Small x and y का transition is defined. X का is not defined. Y का you have. Symbols from gamma also you have added. And that's why we got here in transition function Q along with sigma union gamma union capital B. So these are acting as column headings. Y के लिए it is going to Q4. Y is kept as Y. It's moving towards right. Q1 when processing A stays in Q1. A is kept as it is. It's moving to R. How come? You have entered this data using this self loop. Q1 when processing A keeps it as it is, it moves to R. Same thing for symbol B. When it is processing B, B is kept as it is, it's moving to R. Then there is the transition defined on Y as well as B. So if it is B, it is going to Q2, B is kept as it is, it's moving to left. X का transition is not defined, so it's dash. Y के लिए it's going to Q2. Y is reflected as it is, it's moving to left. I hope these things are understood. Q2. For Q2, there is only one transition defined from it, and that's on B. The rest of them will be dash. So very quickly, we will happily enter dash here. And then for B, we say that it's going to Q3. B is converted to Y, whereas it's moving to left. Done with Q2. Q3 say you got 1, 2 and 3. 3 outgoing arrows. Input symbols are A, B and X. So for B and Y, we have entered dash. A के लिए it stays in Q3. A is reflected as A, it's moving to left. Same with B. It stays in Q3. B is reflected as it is, moving towards left. This dash. X के लिए it's changing the state to Q0. Next state. X is kept as it is, moving to right. What else is remaining? Q4. Q4 say you will find 2 outgoing arrows. one on Y, another on capital B. So this will be dash, this will be dash, Y and capital B का entries only you are supposed to do. Q4 से if capital B is found, next state it goes to is halt. Capital B is kept as it is, performing no action. Whereas for Y, it stays in Q4 itself. Y is kept as it is, it's moving to right. Halt say there is no outgoing arrow. You will find dash in all the cells. So this will be the required transition table wherein you are supposed to mark that this is your final state and this one's your initial state. Mics are provided. In case of doubt, you should ask. Unless and until you are doing it with pen and paper on your own, you are not going to get anything from the designing part. Everything seems same. Why this circle is there, why that circle is there. If you got any doubt related to this, you should ask. Now, the same sum with modification. This was example number 13. Example number 14 says that instead of a raised to n, b raised to n, now design Turing machine which accepts all the strings of the form a raised to n, a m raised to b raised to m, where say n is greater than m. If I say n is greater than m, it means more number of a's are there. At least one more a is there. So number of b's is n. So n should be at least m plus 1. So try to think about this sum, which is sum number 14, and then comes sum number 15, which will say that one more variation, n is greater than n. Means now number of b's are more as compared to number of a's. Finally, you should know that the next variation 16, design Turing machine which accepts all the strings of the form a raised to n, b raised to m. It's asked sum number 16 will necessarily include all the accepting conditions of sum 13, 14, 15. So it will be like this. Design Turing machine which accepts all the strings of the form a raised to n, b raised to n. Most probably they'll give it likewise. n and m are greater than 0. They are greater than 0, but no relationship between n and m is given. So n can be greater than m, it can be equal, or even it can be less. So if you say they are equal, it's sum number 13. If you say they are different, it's sum number 14. If you say n is less, sum number 15. So 16 should have all accepting conditions. And mostly when such kind of sum is asked, students forget to include all three accepting conditions. So step marking will be done. You won't get full mark, even if it's correct for either 13 or 14 or 15. But required accepting conditions are for all three. And that you are supposed to explain as a part of solution before designing. That shows your understanding, that you are clear in your mind and you know that 16 number का sum means 13 union 14 union 15. So try, we have seen this one, theoretical या pictorial solution or explanation of 14 we have seen. So try to design or modify this one. Try to design it from scratch. Take a minute or two. Try to draw it with pen and paper. You may assume that the value of both is at least 1. You may assume. It's always better to start with visual representation in both the cases. When suppose 3 A's are there and 2 B's are there, and next variation, say 3 A's are there but 4 B's are there. I hope whatever I am saying is understood. So this can be represented likewise. Number of A's are more, so you can have A, E's likewise. And if are more, then this will be 3 A's, 4 B's, 3 A's, 2 B's. And this will be On cases are included here. What will be the scenario in this case? That this A will get converted to X and it will keep moving to right till it finds compensating B. A gets converted to X, but B is not there, rather it is encountering immediately Y. If you encounter Y, what you do? You move to its left. Left means you are supposed to find B, but it is finding X. So that will be the accepting condition for example number 14. In this case, 3 B's will get striked off, only this B will be left. As soon as third wala B gets striked off or converted into Y, you will keep moving to left in a search of A. So to locate leftmost A, what you are doing? You are keeping left only unless and until you encounter X. As soon as X is encountered, you move to its right. Right means you are expecting A, but you found B. It means number of B's are more in this case, and that is the format of language. So that's the accepting condition. You will find the accepting conditions के लिए you will have different states. Like in example number 13 में, from Q0 you will get the accepting condition. In example number 14 and 15, it may be Q1, Q2, Q3, Q2, Q1, Q2, Q3. I hope those who are connected are trying to draw it on their own. Let me share the attendance link. Try to find the solution for 14, 15, 16. It's very important sum, frequently asked in university exam. Attendance link is active. It's pasted in the chat section. Anyone would like to share the solution? Mics are provided. Anyone? In example number 16, what you'll do? You'll have 3 halt states, or accepting states you might be combining in single halt state. Either you can have 3 halt states, or accepting conditions, all 3 will be ended in the same halt state. If no doubt, you may switch the lecture.